Okay, this next video, our objective is to determine where graphs increase, decrease, or remain constant. Okay, and it's really about as simple as finding the domain of a function. Okay, when analyzing a graph, sometimes we're interested in determining the intervals where the graph is increasing, decreasing, or remaining constant. Okay, so think about this in a real world context. You have a graph of sales over the month, okay, and what you're interested in is, hey, when were the times when the sales were increasing, or when were they decreasing, or when did it not matter, it just stayed the same all the way through. Okay, so that's what we're going to be doing in this section. Alright, and we're going to use some graphs that are already familiar to us. Again, you want to be moving left to right and make a note of whether the graph is increasing or decreasing at each spot. Okay, downhill means decreasing, uphill means increasing. So you notice that I have my red line, I have it moving, and over that interval the graph is going downward. Okay, so it's decreasing from negative infinity way out here to negative 5. Then it starts to increase. From negative 5 to negative 2, it's increasing. Then it goes down again from negative 2 to from negative 2 to 5. Once again, and you'll notice it popped up right there, it's increasing again from that interval. And then once again, it starts increasing again. Okay? So that's really all there is to it. You just write down, basically in that domain notation that we just talked about in the last section, just write down those intervals where it's increasing and decreasing. Now, we talked before about hard bracket and soft bracket. When we're talking about increasing, decreasing, or constant intervals, they're all going to be soft brackets. Why is that? Well, I'll tell you that in just a second. Hate to leave you hanging, but I want to show you another part of this particular video. Okay? Notice from there to there it's decreasing, then it's increasing, it's decreasing, and it's increasing again. Okay, so think of it that way, and that should make things relatively simple for you. Now, about those soft brackets. If you were going to say about the function that you see right here, that it's increasing from, decreasing from negative infinity to negative 5, and then it starts increasing again, where would you use the hard bracket? Okay? How do you know precisely at negative 5 whether it's increasing or decreasing? We don't know. You can't put it in both with a hard bracket. Okay? And then for those of you who are going to move on to calculus, what you're actually going to find out is that right at those points, I got to back this up. Right at these points where I drew my intervals, this thing is not cooperating. Bear with me. That point right there, it's not increasing and it's not decreasing. It's actually 0. The slope at that point, that instantaneous slope, is 0. Okay? So it's neither increasing nor decreasing, and that is why we use soft brackets instead of hard brackets. Alright, now let's look at this one. Figure out the intervals for which it is increasing and decreasing. Alright, moving left to right again. It is increasing here, decreasing there. Well, there it's not doing anything. It's constant. Then it's increasing, then it's decreasing. Okay, so I would write that as such. Decreasing from -5, oh, for Pete's sake. Decreasing from -5 to -3. Okay, that's right there. Also decreasing from 2, why did I put to 5? Well, isn't that interesting? I need to make a small correction here. This right here is incorrect. It should be from 2 to infinity. Hopefully you guys noticed that. Alright, so increasing from -infinity to -5 and from 2 to 5. And then lastly, this part right here from -3 to 2, it's constant. Okay, so that's how you do increasing and decreasing intervals. That is the end. Goodbye.